Predicting spontaneity of redox reactions. And RxN is going to stand for reaction. There is a process to determine the spontaneity. Step 1, we'll put here, you have to write the net ionic equation. Write net ionic equation. Okay, EQN here stands for the equation. And then step 2, we have to add arrows to indicate the gain and losses. Okay, the gain and losses of the electrons. So add arrows to indicate the gain and loss of electrons. Step 3, you need to identify which of the two metals is stronger as an oxidizing agent and reducing agent. We'll look at a chart shortly about this. Number 4, if the stronger reducing agent has gained electrons, I'll just put here RED for reducing, okay? If the stronger reducing agent has gained electrons, the process doesn't react spontaneously. However, if the stronger reducing agent has lost electrons, the process does react spontaneously, meaning that it's going to proceed forward for the reaction. Also important to note here down on the bottom in stars, when a stronger reducing and a stronger oxidizing agent are on the left side of the equation, it proceeds spontaneously. And furthermore, when the stronger reducing agent and stronger oxidizing agent are on the right side of the equation, so vice versa, it will be the opposite. It will not proceed spontaneously. Let's have a look at some questions and also refer to a chart that pretty much tells us where we can indicate the stronger reducing agent can be placed in reference to the chart compared to another reducing agent. Same thing with the oxidizing agent, where on that chart does it refer it compared to another oxidizing agent, so we can stack up which one is stronger and which one is weaker. Alright, let's start off with this question here, and we're going to be using this chart on the side. As you can see, we're going to be comparing reducing agents with one another. Okay, so like AU versus PT, as you can see, the AU is weaker than the PT. Same thing up here. This BA here is stronger than the CA, okay, because strong reducing agents here are on the bottom. And similarly, when we're dealing with oxidizing agents, it's just going to be in the opposite direction. So AU over here, this ion is going to be stronger than the PT2 plus ion just below it. And I also wanted to have this in reference on the side here on the top for a note about which side of the equation the stronger reducing and oxidizing agents need to be in order for you to determine if the reaction will proceed spontaneously or not. So we'll start with this question, Al. Again, we can see that here it is written as a solid, and we're going to react it with aqueous copper 2 sulfate. So of course it's just going to be CuSO4. So now we're just going to be doing a single displacement reaction between this metal and this metal over here. So we're going to have Al with our SO4. And of course, that was a charge of a 3, so we'll just bring that down over here. Here it has a charge of 2, so we'll just bring it down there. And then, of course, this is again just aqueous. I forgot to write here that this is aqueous, right? It's written in the question. This is also going to be aqueous now. And now we have this, the Cu that is now on its own over here. And that was going to be a solid now. Oh, we also have to make sure that this gets balanced appropriately. So we'll put a 2 over here. We'll put our SO4s. There are 3 of them, so we'll just put that here, and they'll put a 3 over there. Now we're just going to be breaking them up into their respective anions and cations over here and over here, because step 1, that we just looked at shortly in this video, states that we need to create a net ionic equation. So let's create a net ionic equation. So we have our 2Al, keep bringing it down, and then our Cu has a charge of 2, because SO4 was a 2, right? So if we had 2 and 2 down here, these canceled out, right? For the greatest whole number, right? That can be divisible by both. So it had to have been a 2. So it's a 2 plus over here. There's 3 of them. So I'll just put 3 over there. Okay, let's break it up into, there's 3 SO4s, okay? And then the SO4s, like I said, has a charge of 2 minus. Again, this is all in aqueous. This is aqueous. Okay, and then we're going to do the same thing over here. We have 2 ALs, and we know the AL has a charge of 3 as indicated down there. And our SO4, there is 3, okay, SO4s, and of course with a charge of 2 minus. Let's continue. Again, this one is a solid, so we can't do anything with that. And then we are good. So let's cancel out the like terms. So we have our 3SO4 2 minus here, 3SO4 2 minus here. And I think that's it. Okay, so let's continue to bring this down. So 2ALS plus our 3Cu2 plus with our 2Al3 plus. This is also aqueous, and added with our 3Cus. Now, where is our indication of the arrows? Well, we can start with this one, our Al. As you can see, it had an oxidation number of 0, and now it has an oxidation number of 3. So this means that this is oxidation. It increased an oxidation number, right? Which is oxidation. So I'll just put here oxidation, or you could also say lost electrons. So I lost 3 electrons, okay? And then for the copper, let's continue to bring this down here. It had an oxidation number of 2. Now it has an oxidation number of 0. So it decreased, which is reduction, which is also known as a gain of electrons, and it gained 2 electrons. So now let's look at the reducing agents and the oxidizing agents, okay? So this one here got oxidized, right? So that means Cu2 plus is the oxidizing agent. Okay, so let's look at Cu2 plus over here. Okay, let's compare the Cu2 plus with, what are we comparing it with? Obviously aluminum, right? So if we're comparing this Cu2 plus with the aluminum, where's the aluminum? It's all the way down here. Okay, which one is stronger? Which one is higher up? Obviously the Cu2 plus. So what does that mean? Our Cu2 plus here is going to be the stronger oxidizing agent. So I'll just put here stronger oxidizing agent. I'll just put OA, okay? So that is for the Cu2 plus, okay? What is being reduced, okay? So this Cu2 plus was the one that was being reduced. So what is helping that to be reduced? It's obviously the Al. So Al is the reducing agent. So let's look for Al on this reducing agent side. Where is Al? Let me look for Al. I cannot find it. Where is it? Right here, okay? So we have Al over here. And again, we're comparing it with the Cu. So where is the Cu? Cu is over here. All right, which one is stronger? Okay, closer down towards the stronger reducing agent end. Obviously the Al, okay? So the Al is a stronger reducing agent. So, as we look up here, it says when a stronger reducing agent and a stronger oxidizing agent are on the left side of the equation, it proceeds spontaneously. And that's exactly what we see over here. Therefore, it proceeds spontaneously. So we'll start with this one. This next question, calcium nitrate. So we have CaNO3. Of course, Ca has a charge of 2, so we'll just put that down here. NO3 has a charge of 1, so that'll just be down there. Again, this is aqueous. We're adding it with solid nickel. So let's do the single displacement. So our Ni goes with our NO3. This one now becomes aqueous, and now the displaced calcium is going to be on its own, and that's going to now be a solid. So again, nickel can be a multivalent metal, okay? So we're just gonna have to figure it out what it would be on the chart here that we have. It says Ni2 plus, okay? So Ni2 plus is gonna be the charge that we use. So if that's the case, we gotta be putting a small 2 down over there. Now we're just gonna be breaking this up. So again, step 1 always says we have to create a net ionic equation. So we have our Ca has a 2 plus charge. There's no coefficient in front of it, so that's just gonna remain the way it is. We're going to add that with 2, right, NO3s, and we know NO3 polyatomic ion has a charge of -1, and then we have NiS. This is going to break up. Again, nickel has a charge of 2 plus. We have figured out no coefficient here, so it'll just be a 1, and then we add that with 2 NO3s, same thing, 1 negative charge, and we have our Ca stay the same. So let's cancel out our like terms. This is gone, so let's bring it, bring down the rest. Now let's do our little arrows, okay? So we're gonna have our Ca2 plus. As you can see, it decreased in oxidation number. It was a 2, now it's a 0. So this is obviously reduction, also known as the gain of electrons. It gained 2 electrons. And for the Ni, over here, it increases oxidation number. So this is oxidation, and it lost 2 electrons. So let's look at the reducing and oxidizing agents. Okay, so if this is being oxidized, this one here would be the oxidizing agent. Okay, and let's look at this oxidizing agent of Ca2 plus. Where is that here? Ca, where's Ca? That's this one over here, and we're comparing it with nickel, right? So where is nickel? Nickel is right over there. Okay, so as you can see, nickel is stronger. Okay, so this here will be the stronger one. So this one will be the stronger oxidizing agent. Okay, and then we can look at the same thing for the calcium. Okay, so this one was the oxidizing agent. Okay, so if this is the one that was if this one was the oxidizing agent, this is also the one that is being reduced, right? So if this is being reduced, this here has to be the reducing agent. Okay, so now let's do the reducing agent side. So let's get our Ni over here. So where is our Ni? There we have it. We're comparing it with the Ca. Where is the Ca? Ca is down over here. As you can see, it follows the same pattern. The Ca is a stronger reducing agent near the bottom. So both of these are on the right side, okay, are on the right side of the equation, so it will not proceed spontaneously. There we have it. Now let's look at this question over here. We have solid chromium, and you add away the aqueous silver nitrate. So let's do our single displacement. We have our Cr, and again, chromium is a multivalent metal, but we're just gonna have to look for it over here. Where is Cr? As we can see, we are gonna be dealing with the Cr3+. Per our video and using this reference chart. Okay, so this is going to be a Cr3+, okay, and we're going to have an NO3 over here that it's going to be matched up with, right? So if we pair it up with the NO3, that 3 goes down here, that -1 goes down here, which is just 1, right? So there we have that. So that becomes aqueous. But now what got displaced? This one got displaced over here alone on its own, and that's now going to become the solid. There we have it. Now let's break it down into its net ionic equation. So CRS, that continues to go down. This one here was a charge of just 1. Oh, sorry, we gotta quickly balance this out, right? So let's quickly balance. Okay, there's 3 NO3, so we'll just put a 3 NO3 there, 3 AGs on that side, so 3 AG over there. Okay, so now let's continue to break it down. So we got Ag plus, it has a charge of +1, there's 3 of them. Okay, so let's put that there. And then again, we have 3 NO3s, okay, and NO3 has a charge of -1, so let's put that up there. And then again, let's break down our Cr3+, okay, there's just 1 of them. And NO3, there is 3 of them, charge of -1 as well. And we got 3 AgS. Let's cancel out the like terms. Our 3 NO3 over there is gone. Everything else must stay where they are. Let's bring it down just a bit. Okay, now let's do our arrows. Now let's see what we have here. Oxidation number of 0, oxidation number of 3 right now. Okay, in case you're still kind of confused about these oxidation numbers, see the video link in the description about oxidation number, okay, in case you're confused right now about why this is 0 and why this one is 3, okay? So as you can see, this one here is an increase in oxidation number, which means that this is oxidation, also known as the loss of electrons. Okay, and then this one over here, the oxidation number was 1, this is now a 0, so it got reduced, so this is reduction, and this gained. Okay, 1 electron. And I forgot to put over here that this one was a charge of oxidation and charge number of 3, this one is of 0, okay, this one is of 3, so it obviously went up by a count of 3, so we gotta say it lost 3 electrons. Okay, so let's look here first. Okay, this one here is being oxidized, right? So that means Ag plus is the oxidizing agent. Okay, so let's look at Ag plus. There we have it for Ag plus. It's competing with Cr. So where is Cr? Cr is all the way down here. So which one is stronger? Obviously the Ag plus. Okay, so the Ag plus is stronger. So we'll just put here that this is the stronger oxidizing agent. Okay, so then what would this one be? Okay, so this one here is the reducing agent, right? Because this Ag plus is the one that's being reduced, so Cr has to be the reducing agent. So let's look for Cr on the reducing agent side. Over here it's competing with Ag, so where is Ag? Ag is up there. Okay, so obviously closer to the bottom is stronger, so Cr is stronger. Okay, so this one here, I'll just continue to bring this down here. It has a stronger, so it is a stronger reducing agent. Okay, so again, both of these are on the left side. If it's on the left side of the equation, it proceeds spontaneously, therefore it proceeds spontaneously. There we have it. So let's look at this question over here. List 3 solid metals that when placed in an aqueous solution of cadmium chloride will react spontaneously. So something added with cadmium chloride. And where is cadmium over here? We see that. Okay, we don't have to guess. It's multivalent charge. It is indicated here as 2, so I'm just going to be putting a 2 on the bottom there. And then, of course, this is going to be aqueous. And we're going to have to displace it. So this is going to go over here, and this one is going to go over there, right? So CD is going to be alone on its own. And there's going to be something that is with the chlorine now. Okay, so we have no idea what that thing is, okay? And it's going to be with chlorine. Okay, and again, we don't know if it has a particular charge, so we're going to have to keep that one blank down there as well. Now, I'm going to give you a little hint and a little trick for you to know that this one over here, okay, the lone metal that is not existing as a compound, okay, so it is a free element, okay, whatever that one is going to be, that one must be more powerful. It must be more strong than the metal or cation that is in the compound, okay? So whatever CD is, okay, so where is CD? It's this one over here, okay? That particular metal over here must be stronger than it, okay? So we have a bunch of metals here on the bottom here that are stronger, okay? So the Fe, the Cr, the Zn, the Al, the magnesium, the Ca, the Ba, all of these can be representative, okay? If you want, you can pick like, you know, the top two here to be extremely safe, but honestly, even something like just above it, like let's say Cr or Fe, okay, let's just choose Cr in this case, okay? Like the Cr here and the Ca and the Ba, all of these are going to be appropriate. Let me show you why, okay? So let's say we're dealing with Cr. And we've indicated that Cr has a charge of 3, right? So if this displaces the Cd, okay, and now it's going to be with the Cl, okay, has a charge of 3, so I'm just going to be putting a 3 over there, okay, and then Cd is alone on its own right now, and we know that Cd has a charge of 2 plus. So we have Cl here that has a 2, this one here is a 3, so in order to balance it appropriately, we'll put a 3 over there, we'll put a 2 down over here, and we're going to be putting a 2 right in front of the Cr. I think we're good right now. Oh, so we're going to put a 3 here as well. So let's continue to bring this downwards and continue to do our net ionic equation, and let's prove that Cr was the appropriate answer, okay? Just like how Ba, okay, Mg, Al, Zn would be as well. So we have 3 CDs, and again, CD is a charge of 2 plus. And Cl here, there is 6 of them, right? So 3 times 2. Okay, so then we got 6 of them. Cl has a charge of -1. We'll put that as an Aq. And then let's continue to go down to the next side. So we have 2 Crs. And again, Cr has a charge of 3 plus. And we have 6 Cls. So let's cancel out the like terms. So Cl minus, nothing else seems to be a like term. So let's keep going down. So it's 2Crs plus 3Cd, 2 plus, gives us 3CdS plus 2Cr, 3R, 3 plus Aq. So let's continue and do what we always do with our Crs. Okay, so our Crs are going to be over here. As you can see, it has an oxidation number of 0. This one is of a 3, so it increased. So this is obviously oxidation. Okay, so it lost 3 electrons. And this one over here, the CD, CD. As you can see, it gained because it was a charge of just 2, oxidation number of 2 as well, and now it's just of 0, so it reduced. So this is a reduction, and it gained 2 electrons. So let's look at this one here first. Okay, so this one here is being oxidized, right? So if this is being oxidized, that means CD2 plus is the oxidizing agent. Okay, so let's look for a CD2 plus. It's this one over here. We're comparing it with the chromium, right? So as you can see, the CD2 plus is going to be higher, so it's closer towards this end over here, the stronger oxidizing agent. So this one here, okay, is going to be a stronger oxidizing agent. Stronger OA. So if CD2 plus is the one that is being reduced right now, this here is the reducing agent. Okay, so let's look for Cr as the reducing agent. We're going to compare it with the CD. Where is the CD? CD is right up there. Okay, so closer down towards the bottom is a stronger reducing agent, so obviously Cr is stronger. Okay, so this one also follows suit. This is a stronger reducing agent. Okay, so of course, like we said, if the stronger OAs and the stronger RAs are on the left side of the equation, it will proceed spontaneously, and that's exactly what the question is wanting, right? Which of those will react spontaneously? Okay, so this follows suit, not just with Cr, okay, not just with Zn and Al, but also with Mg and Ca and Ba, like I previously stated. Okay, so therefore any of these, right? So like Cr, like I said, or Ca, or even Ba, okay, or any of these that are below the CD, okay, strong reducing agents will work. Okay, etc. Let's try this question over here. If we want solid cobalt, okay, so solid cobalt, to demonstrate a spontaneous reaction between a solid and an ionic solution, so we don't know whatever this cation would be and whatever this anion would be, okay, and obviously it's going to create something else over there, okay. Which of the following aqueous solutions would you use? Again, we're trying to demonstrate spontaneity, okay, so this is very similar to the previous question that we looked at. Like I said, if you want to demonstrate spontaneity, the one that is sole, okay, the one that is alone right now, that is not part of the compound, okay, the one that will be the one that joins the compound and displaces, this one here must be stronger, okay. So we got to look for CO and compare it with this one over here and this one over here, okay. So silver, okay, which is obviously just AA, which would just be AG, and Zn would just be the Zn, okay, and the zinc would just be the Zn. We got to compare, okay, the CO with the Ag and the CO with the Zn, okay. So again, CO must be stronger, okay. So where is CO? Where is CO? This one is the CO, okay. We got to compare with the Ag. There is the Ag, and where is the Zn? Where is the Zn? Zn is right over there, okay. So which one is obviously going to work, okay. So the CO must be stronger, okay. So the CO is stronger than the Ag, but it is not stronger than the Zn, so we cannot use the Zn. We obviously have to use the Ag. So this would be the answer that we gotta use. So therefore, A, the silver nitrate, will be the one to use. That's it. So these are the two green questions of the day. Obviously this is the first one. Okay, there's 3 mini questions below it, and then this is the second one here. Again, 3 mini questions over here. We're going to be using the BA, the CA, and the CR as the lone free elements, as stated in the previous question earlier on in this video. So create the equations for those. Make sure you have this chart handy with you as you do these questions. Please pause the video, try these on your own, and I'll be giving you the answers shortly. This is the answer to the first question. I will slowly scroll down. And this is the answer to the second question. I will slowly scroll down.